Hello, and welcome to the next installment in our customer webinar series, Recall and Stream Best Practices. Today I'm going to be your speaker. My name is Eric Martin. I'm a senior consulting analyst here with the Vectra MDR team, so Managed Detection and Response. We work with customers as an extension of your team in Recall in Vectra Detect. And one of the great things I love to do is help out, dig into data, help customers make sense of what things are, and just really distill the data down and help people understand it better. So some quick housekeeping. So we have down the bottom, you can see we have some resources. You can use the widgets to make the slides and make other things bigger and smaller, tuck them away. We have a question box on the bottom right. I love questions, so feel free to pop those in the question box and we'll get to them at the end. And then also, before you leave, you can please take the survey. Your responses help us make great content. All right, so today we're going to deal with some design patterns. We're going to cover some good things to do, some pitfalls to avoid, some searches, some best practice searches, and some dashboards. A common refrain is to start with the end in mind. Knowing our end goal helps keep us focused and pointed in the right direction. So much of how the purpose of backups is not the backups themselves, it's doing restores. And so I like to think that the purpose of a data lake is not to get the data in, but to get the data out. So Recall and Stream are repositories for the network metadata generated by your network and collected by Vectra Detect. Some common uses for this data include investigations, monitoring, and reporting. So let's drill down. What are some of the end goals with these things? So with investigations, we want to find our data quickly. So we want to, everybody has pulls on their time. Time is of the essence. We don't want to be spending hours to find something. So we want to get our data out quickly. We want repeatable workflows. So not everybody is a master in everything. And so we have more, some people on our teams are really good at this, and we can use this as an education tool to help bring everybody up. But then also, maybe you're just a single person and you did a really cool thing one time, and again, you spent time on that. Well, having to recreate that is frustrating. So if we can have repeatable workflows, if we can save some things and do that over again, we can repeat that. And then we want to filter out noise. So finding data quickly is great. We also need to balance that with the right data. So we want to separate the signal from the noise. So with monitoring, now we're moving into tracking trends. So we did our investigation, we set up something. Let's say, for instance, we're in the middle of incident response and malware is calling out. So we found the host, it's calling out to these indicators of compromise. Well, now let's track it. So now let's have this automation coming in. And that goes into integrations and custom models. Attackers are using automation. People are leveraging automation. If we aren't using automations as defenders, we are just going to be rapidly overrun. And so having these things set up and having custom models so we can see things, integrations with our SOAR engines, that's how we can help leverage these economies of scale. And then finally, reporting. So reporting is not just for incidents. It could also just be a burn down list in general. So we can track overall project health. So one project might be decommissioning all the SMB V1 servers that we have. And so, or the project could be as broad as let's improve our audit score. So as an individual contributor, I've been assigned to get rid of all of the SMB v1 servers, or at least get rid of as many as possible. And my manager has that metric, as well as old DNS servers, older TLS ciphers, etc. And then that goes into management reports, where different people want to see the data different ways. And since it's the same data, however, different people might want to see it differently, and we can tailor that and help people out. So let's look at some design patterns that will help us accomplish this. So really basic, let's naming convention. So we're going to keep it simple. If it's not simple, we're not going to stick with it. And we're going to make it work for us. Vectra slots in everywhere in the maturity model. So we work with people with single-person teams, multi-person teams, teams of teams, and that kind of changes what simple means. Where maybe for you, you're just the person, you can have it, this is the thing I'm working on. When we're in multiple teams, now we need to start tracking things like, we always need to track the owner. Even if you're a single person, maybe tomorrow you won't be a single person. So let's track the owner, let's track the group, the thread of the project that we're working on, and a brief description. So some examples here. I'm seeing a resurgence in Wannacry, so I've been making it a dashboard. We have some things. We have some searches already. I've built a few searches, but we don't have a dashboard for it. So I want to be able to quickly access these things. So MDR, that's the team I'm on. Wannacry, this is about my Wannacry stuff. And an eternal blue velocity. So another piece of information I want on my dashboard is the domain lookups by the host to see how that is. Maybe some hosts are just calling out. Maybe some hosts are calling out and then doing eternal blue. Another thing is investigations. So incident response, maybe wellness checks, anything that we need to do. Let's put a date code on those. And especially with global teams where sometimes we might not know, it might not be evident what date format we're using. ISO standard. So we have year, month, day, that way we have it. And also this has a nice thing of abstracting away. So if we're seeing it, we're not giving away too much data. Although maybe we have to do something and there's multiple users for something. So now Eric Martin, RDP connections, let's track those down. So another thing is backups and version control. So yes, Recall is backed up. I'm sure everybody is backing up their data lakes. However, an errant click can result in loss of visibility. So I was just working on something where I accidentally changed the time scale. I had a relative time, last 24 hours. I wanted to check something. I said this day, and I thought that something was still going on in the background doing some work for me, generating data. Well, it wasn't, and I lost that visibility. So again, we're going to keep it simple. Perfect is the enemy of done. I have plenty of times wanted something to be absolutely perfect. It needs to work this way and scale up, and what about tomorrow? Today, maybe I'm just going to export some JSON. Right? I'm just going to export the JSON. I'm going to put it on my laptop. I'm going to put it on a file share. Maybe tomorrow I'll put it in a version control system so I can track it. But at least though, if I get out the JSON and pop it somewhere, at least now I have the ability to go back and check things out. And you can also play around with it. Labeling work in progress. So just I kind of tend to put WIP, work in progress, in there, because being somebody who's often creating these things, somebody might want to go in and see this new eternal blue search. And they say, oh, this is great. maybe I haven't worked all the bugs out yet. So this will help everybody understand this. This helps self-document it, helps communicate this and convey this information to our team. And then also if we have any versions, putting in the date code, just so that way we don't have this thing copy 1, that thing 1.2 copy 3. We have the date codes in there, now it's easier to use. So less is really more here. So there's a finite amount of searches, concurrent searches, that anything can run. And so if we're needlessly taxing the data lake, that's not going to help us. That's not going to serve anybody. So right off the bat, while we're proving out our things, let's start with a small time scale. 4 hours, 12 hours. That way we can do our stuff, we'll get our results back quickly, and we can kind of play around with it. So next up, let's definitely put the index in there. We're going to be, for the stream examples here, we're going to be talking about Splunk. Splunk will, by default, search some or all indexes depending on various user configurations. In the stream data, we have it, but if we don't specify it, we can be searching everywhere. And that is, again, needlessly taxing. In Recall, we do have to specify whatever index that we're going to. Also, just really quickly, side note on Splunk, quick difference between Splunk and Recall is that Splunk is indexed on read, whereas Recall is indexed on write. So we can change and get more performant searches if we utilize the search speed button. So the fast, smart, and verbose is how much data is indexed, and so we can get data back faster if we want to. So maybe we're looking for something where we know a certain computer. Well, it's rather than just typing in my PC or just everything from the SMB files, let's drill in with my computer, and then maybe the path. Doing this the opposite way, with doing the path first, we're probably going to hit a lot more queries, especially off the file server. So again, we're taxing the engine when we don't need to. And then lastly, again for Splunk, rather than putting the modifiers up at the top, let's cull down the data as much as possible to what we need, and then do our modifiers. And then as we go on and prove this out, we can add more and expand more. Sorry, a little slide. So let's be positive and not be negative. And so not is computationally expensive, especially for Splunk, again, because of the index on read. So not is a wildcard, actually. We need to fetch all the results and then filter for anything that doesn't match that. So this is pretty expensive. So where possible, let's be positive. And it's not always possible. Sometimes you want this thing and not that. However, let's put the nots towards the end so that way we can not keep taxing the engine. So again, avoiding wildcards where possible. So wildcards, asterisk, not, and then bang equals are expensive. So, and there's actually a difference between not and bang equals, where one of them will, depending on if you have data. So if you don't have, say, for instance, the origin hostname field, not will not return it, whereas not, and then you say not equals to something, not will not return it, but not equals will. So again, understanding our modifiers is pretty key here too. And then prepended wildcards. So what I'm looking for is star.google.com is more expensive than google.com/star. So there are definite uses where maybe, again, we're looking for going to that Google example. We want to find all of the suspicious domains that someone's done. So we have a machine that's behaving badly. We're going in and looking at it. Detect hasn't fired any IOCs. we are seeing some other stuff. What has it done? We look at its DNS queries, and there's a bunch of things to Microsoft and Google. So we might want to filter those out. Again, those specific results will return results faster. And then additionally, one thing that we need to keep in mind is that a lack of a field is a wildcard of sorts, and this is like a basic text search. So if we just say I'm looking for 192.168.1.1, that is looking at all the fields. It's doing a string search across the entire record, versus something like id.origin underbar h : equals 192.168.1.1. So maybe we don't know where we're looking for that data, and again, that's fine. However, if we do know what we're looking for, let's tailor these trimmer. Let's verify our searches. Very often we can do something, especially when we start getting into regular expressions. Is it right because we did the search properly, or are we missing something? So let's do some checks. Let's just do some kind of sanity checks here with, do we have the data in an application stream, but not an iSession? Well, should that be that? That doesn't sound logical. Do the results line up with expectations, right? We see this thing on the wire, it crossed this traffic, we do see it, we don't see it. Can we verify this externally? Maybe we see a host, we're trying to track down a malicious host. Maybe we're getting blacklisted constantly. We're getting a report from our information sharing, our ISAC, saying that one of our hosts is calling out and doing a whole bunch of stuff. We turn it off, we're still getting that notice. Maybe we can try to generate some data to see what we're missing, what we're not getting right. And then just some configuration errors. So often I've seen local origin false and local responder false. And so that is getting the data from Cognito Detect, where we're setting up what the local subnets are. And this is often where it's a NAT gateway, some piece of external infrastructure on the public block, or maybe we just didn't put in some other IP address, and that's going out to something. So our NAT gateway is going out to Quad 8. And maybe we actually want that in there. Maybe we don't. There are some differences, there are some trade-offs, but understanding the trade-offs, right? And using this data to find out and understand those trade-offs. So let's take a look at some searches that will kind of help us get things going better. So I mentioned earlier Eternal Blue velocity search. So I have right here the Eternal Blue custom model, which is looking for the data packet that looks like this on port 445 and getting back no responding traffic. And so normally in Recall, we get this back. We get a graph, we get a histogram of all of the things. And we could look at hosts, but if there's multiple hosts, though, we don't know what's going on here. This can lead us to false positives, incorrect conclusions, and maybe have us waste some time. So let's drill down in the data a little bit, and we're going to use timeline here. And so now what we have is now we're going to take this and we're going to get a time slice graph by host. And so now we can see here is a whole bunch of our hosts are hanging out in here. And we can have some false positives where sometimes data looks at this. However, though, what we're looking for with Eternal Blue is a volume, is a velocity where something's coming out and doing something weird. And so it's pretty easy to see here. We have this spike, this host 1, this gold host 1 has these huge spikes 2 days apart where it's going over 600. This is a clear outlier. And it turns out this is our vulnerability scanner. So this thing is supposed to be doing this, which now also has another cool thing of Vectra is helping verify that our vulnerability scanner is working, and our vulnerability scanner is helping verify that Vectra is working. This is great. So we're going to take a look at some searches. And we're going to have, after this, we're going to have a demo. So I just want to talk about a couple of these first, and then we'll go into a demo. So that velocity search, it doesn't just have to be for Eternal Blue. It can really be for anything. One thing also is like an employee cadence. So one of the questions might be, a thing I had was on a Saturday at 8 a.m., some user was doing something. Well, are they normally working at 8 a.m.? So let's take a look at that. And so Timeline helps us out. So here we have ES means Elasticsearch. We can write it all out, but .es will also work. The index that we're looking for in the Eternal Blue scenario, we're looking for iSession. So star will help us with the dates. We're looking at the count. In Recall, our time field is always going to be TS. And Q is the query. Q is just that thing right there in quotes. And we're going to split based on some field. So again, in there, we're basing it on original host name. And then this thing right here, I bolded this because this is magic. Otherwise, we're going to have a really nasty looking legend, whereas this will break it out and get us that nice host name : this thing. So another example would be something like uniqueness and cardinality. So maybe we have and this is again a thing with a customer. We fired a privilege anomaly unusual service insider, and Detect had listed 10 or so different services that were weird, and then we went to Recall and we saw much more things that were obvious. So much more detections, much more services. So the question was, how normal is this, right? How is this within the range? And so now what we can get here is this will break it out and say this user did, or this host called this many unique services over time. So now we have unique services. So how many, the examples for this also include user agent strings. So if you want to find something that might be compromised running a proxy or a VPN, if it's running multiple user agent strings over time, is it running multiple different things that don't happen over time? And when we look at it, just the data line by line, well, in the last 7 days, computer A used Safari on iPhone and something on Android. Well, maybe that's DHCP and it changed. When we look at it this way, well, in the last 3 seconds, it used these ones together. Oh, okay, that's interesting now. And then again here, we can use regular expressions to quickly cut through some domain queries. So again, I had mentioned we're looking for, we don't know what the IOCs are. We're trying to find our IOCs here. And we said, okay, here's all the domains that something did. And we get a ton of stuff. Well, let's filter out domains that we know. And so with regular expressions, and there are some resources for regex here, with regular expressions, we can say something with a literal .windows, and it may or may not have updates. So it's windows.com or .windows.com and .windowsupdate.com. And so we can filter those out. Excuse me for 1 second. So let's take a look at some dashboards that we can make and to help convey this data better. So really quickly, for anybody who hasn't made dashboards before, there's a couple different ways in Splunk to make a dashboard. The 2 easiest ways are when you do a report, we just click on the Save As, and we get report, dashboard, panel, or alert. We can also go from the Vectra Stream app. If we click on Splunk, we can see dashboards, and then we have this create new dashboard. And so what we're going to be working on today is we're going to work on this MDR Wannacry dashboard with a couple different widgets, and this will be what we're going to get out at the end. And we can see here we have our velocity search, we have our hosts that are originating eternal blue, and we have some files that we found. And while one of these things is good, putting this all together paints a much clearer picture on where we have. So similar for recall, we can go in on the left-hand pane, we can go down to dashboard, and we can click on create new dashboard. And then once we create a new one, we're going to get this empty pop up here, and it's going to say, hey, it's empty, let's fill it up. And we can just click on add right here, and we can start populating it with panes. And then likewise, we're going to create one here, again, with our time series data of how this is doing. Again, the account of hosts that are doing it. And then there's no ransom nodes here present. However, though, we do see this host is hitting up the IOCs. All right. So we're going to pivot over into Splunk first, and we're going to do a quick little demo on how to do this. All right. So here we have our finished product here, and so we can see these different panes that we have. So how do we get here is the question. And so what we can do is maybe we start looking for our different things. So if we pop back into Splunk, we're going to pop into search. And so really quickly, one thing that I really like to do is whenever I'm on a new Splunk instance, go to my user and I go to preferences. And I make sure that in my SPL editor, I have the advanced editor on. I have at least the search assistant is at least at compact, if not full. I turn on line numbers and I turn on auto format. And so the line numbers really helps out. So that way, if I'm working with somebody, we can see what's going on. It's just a lot easier to refer to. And then auto format just does a couple of really nice syntactical sugar type things for you. So you hit a pipe and it just kicks it down. That way you don't have this crazy mess to deal with. So we're going to first go for the last 4 hours. We're in smart mode. And what we're going to do, the first thing we're going to do is we're going to look at Cognito Stream. So here's our Cognito Stream index, and you can tell we've already done some of these in the past. And this is a macro. Anytime in Splunk you see with the backticks, something that say this is an index that you get with the Vectra Stream app. So this is telling it we're going to search through here. And then we're dealing with iSession data, which in Stream we have an event type. Is this event type con? And now we're looking for the actual data, right? So we can look at it like this, but we get a whole bunch of things. This is not really super duper helpful. So let's add in our packet and or other things. And so in Splunk, and is implied. So now we have our data. We have this out. This is good, but this is a little hard to read through. We can go through here and look at some things. Although let's try and let's make this a little more useful for us. So one of the things that we might want to look at is let's look at it by time. So we're going to hit that, and we're going to use the time chart function. And what we want is we want the count, and we want by host. And again, because we turned on that helper here, this is coming out and helping us make all these things. This is coming out and just giving us the quick little pop-up info on here. So now we get presented with the time chart and these different time slices that are defaultly picked. So we have this, and we can see 18 at one point in time. So now we're going to go over to visualization, and now, now we see what we're looking for here. Now we have this nice time slice. And maybe since we did this, let's go back, say, 7 days. And we'll look at this thing for 7 days. Now we have something here. Now we have something here that we're definitely interested in. So I'm going to save as. We're going to make a dashboard panel. So we already have one, but so let's make a new one. Right, so MDR, webinar, Wannacry, and the panel title is going to be MDR, Wannacry, or MDR Eternal Blue Velocity. Eternal Blue Velocity. And we want a time chart, and we're going to save that. And then we're going to get, let's view it in our dashboard. And so here we are. So now we have this, and we can now start making this dashboard that other people can use. So we're going to go back to search. And we're going to put something else interesting in here. So one thing we might be looking for is another thing we're going to look for. We're going to look in DNS. We're going to look for those IOCs because Wannacry has that kill switch domain. And originally it was one domain. However, we were doing some looking, and my MDR team, while working with multiple customers, we found that there are actually more kill switch domains now. And so we were able to take that and look at the kill switch domains that we were observing and come up with a regular expression. So what it really comes down to is we're looking for a domain that has this, it has this kind of somewhere in the middle, right? So it's some string followed by this, followed by some string in the domain label. And this is a pretty high fidelity string here. Excuse me for 1 second. So we could look this way. This is kind of expensive. Another thing we can do is we can actually utilize the regex function in Splunk, which is really cool. So we're going to do a regular expression. So again, with the formatter, it's telling us that, yep, we typed this word correctly. And right now it's saying underbar raw. Underbar raw is the entire record. And while we can search for that if we don't know what the field is, we know what the field is here. So since we know the field, we can actually make this faster by saying it's the field that we're looking for. And so we're going to grab this right here. And we're going to punch that in. And so now we have, we're putting it in quotes. So query matches something. Dot in regular expressions is a anything, is any character. Star means 0 or 1 matches, followed by this literal string, followed by any character, 0 or more matches. So we're going to take a look. And luckily for us, we're not finding this. So one thing we could do to validate this is we could do an internal search. I did some testing on a test one, which I can show in the recall. Another thing we can do though is for here, we can just kind of take a look at is like, say for instance, like snake oil, right? So query equals snake oil, and if we want a literal, it's a literal dot there. Snake.biz. Now we have some things here, and let's take a look at the top. Take a look at the top queries. So by default, Splunk will return the top 10. We can do limit equals 5 if we want. And so now we have this thing where we have now proven out our regular expression. We can do a little more with it. So again, what we're going to do is we're going to save as again, and we're going to make a dashboard panel, and this time we're going to go to existing. And now though, since we have a nice naming convention, we can just find it really quickly. And this is going to be MDR Wannacry domains. And we're going to save that. We're going to pop in here again. And so one thing we can do here is, by default, these are not drill downs, as opposed to Recall, which automatically does the filtering. So if we edit our data, if we edit this, go into here, edit the drill down, and we're going to say we want to do like a link to the search. Drill down, link to search. We're going to save this, and so now when we click on this, who went there, we can see it just automatically does this search for us, which is great. So the last one that we're looking for is when we get into a little more regex, is Wannacry encrypted files, right? We never want to find that. In Recall, there's a model that's built in. So I do have to I do need to make one concession for the purpose of a demo. There was no, I wasn't able to rename some Wannacry files, so I'm just going to do a quick rename in here, which is what this is. And so what this thing does right here is, this is going to take a file in the name field, or take a regular expression, and if we have an executable, we're going to rename it with whatever it is, .Wannacry, WNCRY. And this is also good. The other reason why I wanted to show this was, this helps us if we need to sanitize some data, right? So if we're doing something, we can replace something with something else, and we can now sanitize that data. So let's take a quick look. Go to our presets, and we're going to say again, last 4 hours. And so now, we found 9 events that we have our Wannacry data. Okay, cool. Let's open this up a little bit more. Oh, not cool, but good that we found something. So now we have 242. Okay. So now let's take a look. And what we want to do is we want to we have our 242. And so now, this is a nice little regular expression, because Wannacry is WCRY, WNRY, WCRY, or WCRYT. So we can make a regular expression here for that. We can do an or, right? Name is star dot this or star dot that, or it gets really messy really fast. Whereas if we have this regular expression here, it's a little less legible, granted. However, it does help us out and give us a little more workaround. Definitely, though, go into a validate your regular expression, just to make sure that you're getting the data that you are looking for. So now let's take a look at the top hosts again, because that's where we just want the data. We want, who are the hosts that are doing this? So top id.origin _ h. So all right, we have 242 records that have been returned. Let's actually go down a little bit just to the last 24 hours. Make this a little bit easier. All right, so 143, 125, 18. Still doing well. Awesome, good, okay. IP addresses are okay, but what I really want to see is origin name. So we're going to add that in there. And so we still have 143, but why don't we have any data here? And so it's not a typo, because if we go back and we say ID.responder under RP, right, we'll still get this. So this isn't a typo. This is just a problem with data. And so, and this is what I was talking about with validating, where the problem is if we go back and look at our data, what we're going to see is there is no origin name here. We don't have that field. And so since we don't have that field, when we want to do a top on that, we can't, because it doesn't exist. So how do we fix this? Well, what we can do is, Splunk has this cool thing called fill null. Value equals none. And it just says if there's anything that's null of these fields that we're going to say, fill it with something. So we're going to fill it with the value none in capitals. That way it's pretty clear to us. And original underbar hostname. Oops. There we go. So now we have this thing here that they were there. And again, just to prove that we did this properly. Yep, nothing there. And now it's there. Awesome. So now we can go back, and again, we can make our and save. Make our dashboard panel. Existing MDR. Right? And so we want a statistics table. This one here, and we're going to view it. So now we have this thing. Now we know who's going out to these. Who's going out to these? Oh, we didn't put a title in it. So now we didn't put a title in, it makes it a little bit harder to read. So we can just go back in. Right, MDR Wannacry hosts with. If we want to go back in here, if we want to edit the search, we can always go in here. And maybe what we want to find is not the original host name. I mean, that's important, but we also want to say add in the host that it's going to. And so now we have that host there that it's going to. And we can remember to save this. So we have here, and so here we have our known ransomware extensions. And again, if we look into here, we just kind of see this. And also the great thing is we can go in here, and if we have something particularly clever that we did, we can always go in and take a look at it. Right now it's using the time picker up top. We can make another one. We can set whether or not we want to auto refresh. And then always, if we want to look at it, we can always go to the source. And we can just grab this out, and we can save this. And that way also, if something gets bumped, if there's some issue in there, we can always go back. And then if we do like dark theme, we don't like dark theme, you can always just refresh it. So, taking a look at recall. So here we have our search. Again, in a really fun tool into his timeline, and so that was generating the different things for us. So again, we're going to go to our open searches here. We're going to open up a search. And what we're looking for is Eternal Blue. We're going to say last 24 hours. So again, we have a host doing something. In this case, it's just one host. So we can go in here. And so what we're looking for is this thing right here. So index, if we look at our index, right there, that tells us what we want to do. So metadata underbar iSession $. Time field is always going to be TS here. Index equals metadata. And it starts, as you can see, it's starting to help us out already here. Time field equals TS. Metric equals, it's going to start saying, oh, what do you want? I want count. Q equals, and we're going to put this in quotes. And then what we're looking for is the origin hostname. Here we do not have a default, so we do have to say 10. Last 15 minutes gave us nothing. What about, we knew last 24 hours. There we go. So a couple things. Like Splunk, timeline is white space agnostic. And so this can be a little hard to read. So if we want to, we can always just look at our on our commas, just like some people have written SQL, and just kind of break these out. It just makes it a little more comfortable, a little more legible. And we can see what's going on here. And so like I said, this is right here. It's taking this whole query and then doing this. So we're going to look at some, this is like the perfect label that 80-20 rule, like 80%, 90% of the time this label is perfect. Label, we're using regular expression capture groups. So $1 is the first capture group, and we set that up by using parentheses. So what we're looking for is something, anything, followed by a space, followed by a caret. Right, so we're looking for anything followed by a space, followed by a caret. And then we want to followed by a space, and then we want to grab something and put it in our capture group. And then, because this is what we want right here, this origin hostname colon, whatever it is. Then we want that count. And so now, we can look at this, and now that just gets reduced down to the origin hostname. And if we have multiple hosts in here, it will do that. So we can grab this right here. Have this one right here. So we're going to look at the last 15 minutes. Well, that's good. Now we can have, yep, we have our Kali box. Now we can see that, do that, and these just work back and forth just fine. So let's take a look at our, let's take a look at making some other ones. So if we go to our dashboard, we go to our dashboards here. So here's our dashboard. And here we have, took that up for a second. So everything's going to be pinned off of this. So the way I'm grabbing things is we're just adding in there. So if we go to edit, add, and we just grab any panel that we want. So MDR, internal blue originating hosts. I'm going to add that in there. So we have our originating hosts. So if we want to go and edit this, we can inspect it, we can edit it. And now keep in mind, though, this is going to edit the underlying visualization. So we can see in here, this much like Splunk, it's going to edit it, so we need to be careful of that. But we can pull it out, say we want to do, I guess I want to add in a sub bucket. Terms, I need an origin host. Put in our IP address. So I know we're going to save that. And now we always have the opportunity, do we want to save it as a new visualization, or do we just want to overwrite the existing one? Back to our dashboard. That in there. Some of the things that we're looking for are trends. And with timeline, what we can do is we can look at trends over time. So what we can look at is, say we have a search where we have, what we're looking for is how many things are going out, what's our velocity just look like. So we'll do a kind of expensive search. Just get rid of that. So what's our traffic look like over the last 7 days, right? Maybe we're looking for SMB v1 hosts. SMB file star and Q equals version colon SMB v1. So right now we're not seeing anything. We're looking for SMB v2. So we have one host here. So let's look at the trend. So maybe we're looking for a trend to see how that works. We have a really cool one, trend. We're going to type properly. And what this will do is this will get rid of this search, but we'll replace it with a trend line. So then we kind of see that kind of goes up. If we want to superimpose it on that graph, add a comma in here, and we'll just copy that. And so now maybe then we'll just change this label here to, we can now have a trend. Now we can kind of see where this trend line is. So we're going to pause here for a second. I have a question in chat about metadata attributes. What are they? Where can I find them? What do they mean? So yeah, so doing our efficient searches, we definitely need to know our metadata attributes. On the Vectra website on support.vectra.ai, Vectra and Stream Recall Metadata Attributes, we have up a nice sheet here with all the quick, what everything means. So TS is our timescale. Really the important ones are ID origin H, which is our originating IP address. Origin _P is our originating port. Responder H, responder P, again, responding host, responding port. And you can scroll through these and grab them down. And that really helps out with when we're dealing with things to come in here. Now for reporting, maybe we want to make up something else where trend lines is really the big thing. Maybe we want a graph of how many things are going against SMBv1, how many things are going against whatnot. So what we can do here is we'll make our, maybe it's a number, right? So we have this thing here. And one easy way to do this, to add this in, is just, again, the overall count just of everything, say, of, like I said, SMBv1 host. So pull this in. Going through here, and this can also help us if we're not as comfortable with the metadata attributes. Popping this add a filter will give us the filters for this. So we can go in here, version, say is, and just start adding it for us. So that can definitely help out when what we're looking at is this. And so maybe we want to see this right here. And so we can maybe we want to look at this. And what we want to do is we want to be able to report to somebody, here's what this is. So what we do is we can go into visualize, make a new visualization. And we just want, say maybe a gauge, or just a distinct number, right? So, or maybe a goal, right? So now we can say metadata SMB files. And so this is right now 53%. Well, that's not good. We need to knock that down, right? So split group terms. Keep typing name, version. And so now we can kind of see the breakdown here of what this is. And so now this is a nice quick heads up dashboard for management of, rather than here's the ones, well, what's this breakdown? And so I always say with the VSA, we have the Vectra Security Assessment Dashboard. It is a great dashboard. It's a lot of data, and that helps us pass the audit before the audit, right? So you have the external audit come in, and then InfoSec is maybe trying to do an audit on a regular basis to make sure that we pass, and then we have our dashboards up every day controlling our work. So now we can take this, save this, and we can say type MDR SMB by version. And so now we can start building these in here. Go into some dashboards. We can start having a burn down for our work of, let's add this in, right? Since we have MDR. Gonna start having these come in, close it up. Now we can start building these in, and we can pull in a trend here. We can pull in all these different things. SMB files. So we have that one host there. Maybe it's not the original host name that we want to know. What we actually want to know here is the responding host, right? So this is, let's look at this responding host. There we go. So now we have this responding host. And then again, maybe we're looking for, we need to show some movement here, right? So we had a bad finding on our audit before, or maybe we're just trying to keep tabs on this. Let's just take a look here. And let's see how that trend works out. So we can kind of see where that is. That with the label. All right, well, thank you very much. I'm going to post these dashboards and searches up to our GitHub after this, so that way you can use them and integrate them and build off of them. If there are any other questions, please feel free to pop them in the chat. And I appreciate your time today. Oh, also, feel free to grab